Let's take a look at an example in which we can compare a more complex model to a simpler model in this cross-orderings pattern analysis procedure. Now, you might do this sort of thing with traditional statistics when you run a simple regression model, for example, and then you add in another predictor to see if you explain a significant proportion of the variance in the dependent variable with that more complex model. Now, of course, in OOM, we did not talk in terms of variance explained. Instead, we're going to focus on accuracy, and particularly we're going to focus on the percent correct classifications index. Do we see a substantial increase in that index from the simpler model to the more complex model? So let's return to these therapy data. Recall that we have three therapies here, therapy 1, 2, and 3, just labeled generically. We have outcome here, clinical outcome, it's either positive or negative, and then we have a gender ordering, that's male or female. So let's start with a simple model. So we'll select analyses here and the pattern analysis, and we're going to cross the orderings. Just double click here, move therapy over. I could select the variable or ordering rather and move it over. So I've got this simple pattern comprised of these two orderings. So I'm just going to magnify this so we can see what's going on. And let's suppose that our expectation is that most of the individuals will respond positively to therapy 1, therapy 2, and therapy 3. So there is our simple pattern, expected pattern where we hope to see most of the observations. So I'll select OK to accept that. And let's go ahead and just run the analysis. And we're taking the text output window. Here we see the pattern. Again, notice the blue crosses there. And then we have 500 individuals in this study, 357 matched expectation. So that's 71.40%. So that is our percent correct classifications index. Seems like a fairly impressive result. Now let's suppose that we think there might be gender differences with regard to the therapeutic outcomes. So we need to include that ordering in a more complex model with the hopes of increasing our PCC. Now, one way we can do that in a purely post hoc fashion in the software is to go back to the analyses, the pattern analysis, and crossed. Now let's go ahead and move gender over into that third ordering. And now we'll define the pattern. So now we've got a more complex pattern to work with. It's a three-dimensional pattern. So notice here we are working with the males, or we could toggle to the females. So let's start with the males, and let's take a look at all the observations for the males. Now we can see, let me magnify this a little bit. We can see that, sure enough, for the males, a majority of them are responding positively to therapy 1, 59 versus 9. So we'll go ahead and select that as our expectation. And then 55 to 12 and 107 to 17. So this model or this pattern seems to fit really well for the majority of the males. But now let's take a look at the females. Here for therapy number 1, we do see a majority. It's not as large of a difference as we saw for the males. Let's go ahead and select that cell for our expectation. And then we see for therapy number 3, again, 80 to 56, a majority again positively responding to the therapy, not as large as for the males, but nonetheless, we'll select that. But then here we see a bit of a difference. So the majority of the females are not responding positively to therapy number 2. So if we alter our pattern like so, then we have a slight difference between the males and the females, and it's different than the simple pattern that we ran a moment ago, which just ignored the male or female ordering. So again, we go back, here's the male pattern, here is the female, or I should say the male aspect of the pattern, here's the female aspect of the pattern, but it's one overall three-dimensional pattern that we're going to now test. So let's go ahead and select OK to accept the pattern, and let's select OK here to run the analysis. So notice now the pattern for the males here, notice the blue crosses, and now for the females, notice the blue crosses here. So that is our three-dimensional pattern, and we can see that the PCC increased to 73.20. So 366 out of 500. So it did go up a little bit from the 71.40, so 357, 500, 366 to 500. Not much of an increase there in that percent correct classification. So it doesn't appear to be all that important. However, in the clinical domain, this might be important. So as with traditional statistics, beware of any sort of general rule for interpreting effect sizes. In this case, the effect size would be the increase in the PCC from the simple model to more complex model. This approximate 2% increase may be something worth talking about in the clinical realm. Now, in a subsequent video, I'm going to show you how you can test this approximate 2% increase against physical chance using a randomization test. So can we even rule out physical chance with regard to this approximate 2% increase? And that might help us then to decide whether we really want to pursue even a clinical interpretation of this approximate 2% improvement from the simple model to the more complex model.